everybody, Mr. Covey here, and this is the third rational functions video. Okay, so we're going to look at one final kind of weird situation that you might encounter, kind of like a special situation. It requires that you know both long division for polynomials and synthetic division. If you're a little rusty on those from first semester, I put 2 videos in the folder that just go over those processes. Like, this is how you do long division, this is how you do synthetic division. So if you are having problems with that aspect of this, go and watch those videos to make sure you have those 2 processes down. Okay, so let's dive into this. This is kind of just one added layer on. So we're still going to do our normal stuff, which is we're going to try and factor. If you look at this numerator, what multiplies the -1 adds the negative? Nothing. So you're kind of stuck in that aspect. There's no real factoring to be done there. To find my vertical asymptote, I still set the denominator equal to 0. So I still get x equals -3 as a vertical asymptote. I'll graph that real quick. Okay, so I still have that vertical asymptote. My domain, that's my only restriction, is -3, so I can go from -infinity to -3. Can't hit -3. Pick right back up to infinity. There's no holes, there's no removable discontinuities because there was no common factors in the numerator and the denominator. So, and we're going to come back to the asymptote and behavior idea. But let's find our y-intercept real quick. We plug in 0 for x, we get -1/3. So my y-intercept's 0, -1/3. Plot that. And then to find my x-intercept, I set my numerator equal to 0. This is a little bit annoying because, as we noted earlier, this doesn't factor. So if I want to figure out where that equals 0, I'm going to have to use my quadratic formula. Opposite of b plus or minus the square root of b squared for ac all over 2a, but just 2. Clean that up a little bit. It'll end up being 3 plus or minus the square root of 40 over 2. Okay. If I'm going to actually write the x-intercepts, I should write them in exact form and maybe even simplify that a little more. So it would be 3 plus or minus 2 root 10 over 2, so plus or minus the square root of 10. Okay, so if I was going to write those as points, I'd write 3 plus square root of 10 comma 0 and 3 minus the square root of 10 comma 0. If you're trying to estimate what the square root of 10 is without a calculator, well, you know the square root of 9 is 3, so it's a little bit more than 3. So this one's going to be a little bit, just barely below 0, 0. So it's going to be like right there. This one's going to be 3 plus a little more than 3, so it's going to be a little more than 6. Okay, so I got my 2 x-intercepts there. And the real thing that's weird about this one, or new, is that we know that it doesn't have a horizontal asymptote. And that's because the degree of the numerator is actually bigger than the degree of the denominator. But it's actually, since it's exactly 1 degree higher, in other words, since it's a squared over a first degree, it's not going to have a horizontal asymptote. It's going to have what we call a slant asymptote. Okay, so this is kind of weird. But basically, instead of having some line here that it goes towards, there's going to be a line, not horizontally, but some line at a slant that the graph is going to go towards at the ends. Okay? The reason this happens is because if you do something squared, let's just think of the simplest squared thing we know, x squared, and you divide it by x and you simplify it, it is just x. It's linear. It's a line. So when you do that division, you end up getting a line, and so this is going to approximate that line. Now, this is more complicated, so it's not going to approximate just y equals x as our slant asymptote. We're going to have to figure out what line to do for our slant asymptote. The way we figure that out is with division. So we're actually going to divide this by this, and it's going to tell us our slant asymptote. Okay? You guys totally can do this. It's not too bad. Luckily, I can use synthetic here. So a reminder, I'm going to put a -3 in my box. Here are my coefficients. I'm going to go through my process. Remember to interpret that answer. So this tells me that when you divide that, you get x minus 9, and then the 26 is my remainder. The nice thing is we're not going to worry about the remainder at all. It has no impact whatsoever. This is our slant asymptote. Okay, so notice we changed this to just say asymptote. That's because we're not going to have a horizontal one. Instead, our asymptote is going to be this line, x minus 9. We should graph that asymptote. Okay, so x minus 9, also a y-intercept of -9. It's got a slope of 1. And it's an asymptote, so I should graph it dotted. There we go. To find the end behavior, the slant asymptote actually makes our job really easy. Because as the graph goes off, it's going to get really close to this line if we zoom way out. Well, that line, as I go to the right, is going to infinity. So as my x values go to infinity, my y values are going to go to infinity because it's going to get closer and closer to that line. Likewise, if I go off the graph to the left, as x goes to -infinity, my y values are going to get closer to that line. Well, that line is going to -infinity. Okay, so all you have to do is look at that slant asymptote to tell the end behavior there. I have everything. I just need to sketch this graph. Here, I have these 3 green points. I know what the graph looks like here. It's got to go close to that vertical asymptote. It's going to sweep down here. It's got to hit that. It's got to hit that. Because then at the end of the day, it's got to be approaching this slant asymptote. So that red's going towards that blue. And right here, it's going towards the green. Now there's another chunk of the graph. It's kind of off the graph on this one. So let's just plug in 1 point, -6, to see where that other chunk is. So let's jump up here, take a second to plug in -6. You get 71 over -3. So it's like -22, 3, 4, something like that. So at -6, the graph's actually way down here. And I know this is off the graph, so I don't really want to worry about it. But if you think about how this is chopped up again, way down here, our graph looks like this. It's kind of a similar shape to there. Okay. If you jump over to Desmos with me, you'll see what the slant asymptote actually is. So here's the graph we just graphed. The slant asymptote says if you zoom really far out, what does this look like? Well, it looks like x plus 9. It looks like that line. You see the slope of 1 there? So big picture, this function looks like x minus 9. That's what it looks like. Okay. Cool. Let's jump and do another one. Okay. So I'm going to factor. What multiplies -4 adds a 6? Nothing. Numerator doesn't factor. X equals 2 is my vertical asymptote. So once I have my vertical asymptote domain, there's no hole. Figured out my y-intercept. Figure out my x-intercept. I'm going to have to do quadratic formula again. Pause and do that real quick. So you finish up your quadratic formula by setting the numerator, because we're setting the numerator equal to 0 to find our x-intercept. Simplified, you get those. Square root of 13 is between 3 and 4. That's all you need to know. Here are my x-intercept. Okay. And then the last thing, the new thing, is since the degree of the numerator is 1 more than the degree of the denominator, it's not going to have a horizontal asymptote. It's going to have a slant asymptote. Now, when I do this division, I'm going to have to do long division because I have a coefficient in front of the x. Okay, so this is long division I have to do here. I'm going to slide down here and start that process. You go ahead and start it. We'll check in midway through. I realize you might hit a little snag at the beginning, so let's do it together. What do you multiply 3x by to get x squared? Well, you multiply it by 1/3 x, right? That's how you get the 3 to turn into a 1. Okay. So then I get an x squared. What's negative 6 times 1/3 x? That's negative 2x. Okay, and I'm going to subtract. Don't forget you're subtracting. Number one mistake. 6 minus negative 2 is 8x. Okay, I know these numbers are a little messy, but you kind of got to deal with it. What do you multiply 3 by to get 8? Well, you multiply it by 8/3. Right? Because you want to add in the 8 and you want to divide out the 3. Okay? We can actually stop here. So we don't have to finish the division because we don't care about the remainder and all that stuff. As long as you made that decision right, we are done. We're in business. Here's our slant asymptote. Y equals 1/3 x plus 8/3. Okay? I'm going to graph this line. So 8/3, terrible 8. Come on, Mr. Guy. 8/3 is a little bit less than 3, so that's my y-intercept for my asymptote, my slant asymptote. And then the slope's 1/3. Rise 1, run 3. Rise 1, run 3. Rise 1, run 3. Okay, so I'm going to draw my slant asymptote there. Cool. So I have these 3 points here, and I know that at the end, it's going to approach that slant asymptote. So it must come up like this. Loop down like that, and then go down toward that black asymptote. That's what the graph has to look like. Now over here, I hope you're starting to see patterns. I don't know, I haven't graphed this yet, but I'm thinking that when I put in x's like 5, it's going to be up here. That's probably what it is. We should definitely check that, but I have a feeling. Okay, so let's jump here. If you want to make a little table real quick, I'm going to plug in 5 for x. Do that real quick. Okay. So when I plug in 5, I get 51/9. That's what, a little more than 5, a little less than 6. Right about there. Okay, and so it does work out like I think. Like we thought. Okay, so it kind of loops down and then it must loop there. Okay, so my end behavior, again, look at the purple line. As you go to infinity, the purple line is going to infinity. As you go to negative infinity, the purple line is going to negative infinity. So that's what our end behavior is for our graph as well, since it's approaching that purple line. I know this is a lot of work for these problems, but you guys can do it. This last one is a little bit weird, and I'm actually going to tackle it in Rationals Video Part 2. So if you could skip now to Rationals Videos Part 2, and we'll do this third example together. Thanks.